I'm Margaret Ann Orgill, and I'm External Communications Manager at the Institution of Mechanical Engineers. Today I'm talking to Professor Tim Baker from University College London about an exciting project he was involved in to develop a new breathing aid for patients with COVID-19. Tim's also heavily involved in the work of the IMechE and is Vice Chair of our Design Challenge competition. Thanks very much for joining us today, Tim. Can you tell us how this project came about?
Sure. Well, the project came about for me almost by chance, by bumping into a colleague on a ordinary day at work, and they were working on something that looked like a part of sort of PPE, a mask for the COVID situation. So we got talking, and one thing led to another, and then within 24 hours I was meeting the intensivists that run the intensive care unit at UCL, the hospital, and the conversation was all about what we could do to help with producing breathing aids to treat patients in the hospital. So that's where it all started from, and we were asked to look at a slightly different device, so not a mechanical ventilator, but a device that produces oxygen at slightly high pressure. So continuous positive airway pressure is the name of the device, or a CPAP. And the reason they were doing that is because it fits in between sort of simpler techniques and sort of the more intensive ventilators. So the idea being that they'd spoken to their colleagues in Italy and China, and they'd learnt that this is what they had been doing, and there was a need for CPAP as a means of potentially keeping patients from progressing onto full ventilation.
And what were the main challenges of the project?
Sure. Well, obviously, apart from the timescales, it was quite a challenge. We were having to make a lot of devices in a very short space of time, and trying to do that in a sort of a manufacturing sector that was going into lockdown. So communication was really important to get people to understand the importance of still being able to supply and do the manufacture. So we were very fortunate. We've got very good links with the Mercedes Formula One team, and in particular the high performance powertrains, and they were able to support us through the design and the manufacture of the device. But it was certainly very a real challenge to keep things going when most of the people were working remotely or from home.
And what were the surprises that came out of this project for you?
The surprises, I guess, were the challenge of doing everything so quickly. I guess how much you can achieve in such a short space of time. I think when we had our original meeting with the medical team, if we'd been told that we were going to be producing 10,000 units within 4 weeks, I don't think I would have believed that. And I think I would have been, very apprehensive about taking on the challenge. But, amazing to think that that's what we did. Within 4 weeks, we had delivered our commitment to the NHS of 10,000 devices. So that was, a real surprise to be able to do that.
And what were the learnings for you from this project? Anything you'd like to highlight? Yeah,
sure. I mean, the learnings, communication is very important. A lot of what we did, apart from doing the manufacture, we also set up a logistics company to handle the distribution of all the devices. And I think that's one of the things that I would say that engineers are very good at the problem solving, the organisation, and talking to people was the key. I probably spent most of my time on the telephone when all of this was going on, just to be coordinating the whole project.
And in your role with the design challenge, are there any learnings that you think you would pass on to participants in the competition?
Yes, it was very interesting. So in terms of what we do with the design challenge and teaching students, I'm always very keen to emphasise the need for whatever you produce is credible, and when you're trying to convince others about the merits of your project. So we really put all of that into practice. So in some ways, our group was a bit of an outsider because we weren't part of the main ventilator challenge that was being backed by the cabinet. Although we did become, part of the sort of the cabinet project. So it was very important for us to have very good, clear engineering information presented in terms of assembly drawings, having all of the parts list in terms of a bill of materials right from the very beginning. So we put a lot of effort into making sure that everything that we presented was of the highest quality. I think it really brought home how important that is as part of the engineering process. Students often think that they like doing the creative part of the design and the analysis and the engineering and the science, but they probably see that the sort of the parts lists that go with that are not the most exciting part of it, but they're absolutely they're a crucial part of what we do as engineers.
Oh, thank you very much for sparing the time to speak to us today, and many congratulations on the successful project.
Well, thank you very much, and thanks for giving me the opportunity to talk about it. Thank you.